Amazon Web Services gives you two places to store a secret, and they look nearly identical. Pick one and you pay 40 cents per secret every month. Pick the other and you're hand rolling the rotation code you could have bought. One direction costs money, the other costs a weekend. Stack Lessons, Episode 6. Here we go. By the end of this video, you'll be able to look at any scenario and instantly know whether it calls for Secrets Manager or Parameter Store, and how to fetch either one at runtime without hard coding a single credential. This sits in the Design Secure Architectures domain, and the whole decision comes down to one scenario we'll keep coming back to. Quick recap before we start. In Episode 5, we covered how KMS gives you envelope encryption and customer-managed keys to protect data at rest. And back in Episode 2, we saw how an instance profile attaches an IAM role to an EC2 instance. So that instance gets temporary, auto-rotating credentials with no keys stored anywhere. Today we lean on both of those ideas to store secrets and fetch them at runtime, without ever hard-coding a password. Let's pin down 4 terms you'll hear throughout this video. Parameter Store is the configuration store inside Systems Manager, and its standard tier is free for up to 10,000 parameters per account per region. A SecureString is a parameter store value that's encrypted at rest with KMS, and decrypted only when an authorized identity retrieves it. Secrets Manager is the paid service built specifically for credentials and tokens, and automatic rotation is the one feature that sets them apart, where a credential gets swapped on a schedule and both the secret and the database are updated. For supported databases like RDS and Aurora, Amazon Web Services handles that rotation fully on your behalf. For other secret types, you supply a rotation function that does the swap. Here's MegaCorp's actual situation. They run 14 microservices, and each one needs a database password when it starts up. Right now, those passwords are pasted straight into EC2 user data as plaintext. That means the credential is readable in every snapshot, every machine image, and by anyone who can open the console. On top of that, the security team wants those credentials to rotate automatically, and they don't want to rewrite 14 applications to make it happen. 2 Amazon Web Services can solve this, and at first glance, they look almost the same. The trick is knowing which one this problem actually calls for. So here are our 2 candidates side by side. On the left, Parameter Store, a free standard tier SecureString values encrypted with KMS, and room for both plain config and secrets. But notice that red line at the bottom, no built-in rotation. On the right, Secrets Manager, 40 cents per secret per month, the exact same KMS encryption, and it's built specifically for credentials. And down at its bottom, in green, the thing the other one lacks, automatic rotation. Read the caption and you've basically got the whole episode. Both encrypt with KMS. Only one rotates for you. Let's look at Parameter Store first. At its core, it's a centralized store for named values, and it supports 3 types: plain string, string list, and the encrypted SecureString. The standard tier is free, giving you up to 10,000 parameters per account per region, with a 4 kilobyte limit on each value. If you need more room, the advanced tier raises that to 8 kilobytes and 100,000 parameters, and adds parameter policies, but that tier costs money. Now, here's the part that matters most. The SecureString value is encrypted at rest with KMS, the very same encryption Secrets Manager uses. So for a secret that just needs to be encrypted, Parameter Store gives you that protection for free. Reading a SecureString at runtime is a couple of lines with the SDK. You call getParameter with the parameter name, and you get the value back. But there's one detail that trips up nearly everyone the first time. See that with decryption flag set to true? If you leave it off, KMS never decrypts the value, and you get the encrypted ciphertext back instead of the actual password. The call succeeds, so it looks like it worked, but the string is garbage. Set with decryption to true, and the authorized identity gets the plaintext. So if Parameter Store gives you the same encryption for free, why would anyone ever pay? Here's the answer. Parameter Store has no built-in rotation. It stores your secret and it encrypts it, but it will never, on its own, generate a new password and swap it in the database on a schedule. That single gap is the entire decision. Everything else about choosing between these two services flows from this one missing capability. Now, Secrets Manager. This service is purpose-built to store, retrieve, and rotate database credentials, API keys, and tokens. It charges 40 cents per secret per month, plus 5 cents per 10,000 API calls. For that fee, you get built-in automatic rotation. For natively integrated databases like RDS, Aurora, Redshift, and DocumentDB, Amazon Web Services runs that rotation fully on your behalf with no Lambda function in your account at all. For other secret types, rotation runs through a function you provide, either custom or from an Amazon Web Services template. And it adds 2 more things Parameter Store can't do. It can generate a strong random password on demand, and it can replicate a secret across regions, so a multi-region app reads a local copy. Those 2 features are secondary signals. If a scenario mentions generating a random password or cross-region replication, that's pointing you at Secrets Manager. Here's how that managed rotation actually flows. Secrets Manager triggers a rotation Lambda function on a schedule. That Lambda runs a 4-step dance. It creates the new secret, sets it, tests it, and finishes by promoting it. Behind the scenes, the pending version becomes the current version once testing passes. And here's the nice part. For natively integrated databases like RDS, Aurora, Redshift, and DocumentDB, Amazon Web Services manages that rotation Lambda for you, so it updates the credential in both the secret and the database itself. For other secret types, you supply your own Lambda. You can schedule this as often as every 4 hours. This is the one thing Parameter Store simply cannot do, and it's the whole reason a paid service exists. Amazon Web Services actually draws this line itself in the Parameter Store documentation. The way they put it is that for secrets like database credentials, API keys, or tokens, they recommend Secrets Manager because it provides purpose-built controls including automatic rotation and cross-region replication. And then they add that Parameter Store encrypts values using KMS. Read that carefully, and it's the whole decision in 2 sentences. Parameter Store encrypts. Secrets Manager encrypts and rotates. The vendor is telling you exactly where the boundary sits. Here's the picture that makes this stick. Parameter Store is a locked filing cabinet. Your papers are safe inside, but if you ever want to change the locks, you have to do it yourself. Secrets Manager is that same locked cabinet plus a maintenance service that shows up on schedule, cuts a new key, rekeys the lock, and hands the fresh key to the right people. Both keep your papers safe. The difference is that only one of them includes the recurring rekeying labor. And that labor is precisely what your 40 cents a month is buying. If nobody ever needs a new key, you're paying a locksmith subscription for a closet that never changes. So here's the one-line rule to carry into every scenario. Do you need to automatically rotate database credentials? If yes, the answer is Secrets Manager. Do you just need cheap encrypted config or feature flags or values that never rotate? Then the answer is a Parameter Store SecureString. That single question answers the large majority of questions on this pairing quickly and correctly. When you read a scenario, the phrase automatically rotate is your cue. Now let's put real numbers on the mistake. Take 200 plain application config values. In Parameter Store's standard tier, that costs you $0 a year. Put those exact same 200 values in Secrets Manager, and at 40 cents each per month, You're paying around $960 a year. That's the price of paying for rotation on values that never rotate, and it only grows as you add more. The encryption is identical either way, so every one of those dollars buys you nothing when the value is static. Let's match the store to the need. Reach for Parameter Store when you got feature flags and application config non-sensitive or rarely changing values, or encrypted secrets that never rotate, and you want zero cost at the standard tier. Reach for Secrets Manager when you have database credentials that must rotate automatically, when you need a generated random password, when you need to replicate a secret across regions, or when you need simple cross-account sharing through a resource policy. On that last point, Parameter Store can share values across accounts too, but only advanced tier parameters and only through Amazon Web Services Resource Access Manager, which is more work to set up. Secrets Manager attaches a resource-based policy directly to the secret, so when a scenario stresses simple, flexible cross-account access, that's the cleaner answer. Now, whichever store MegaCorp picks, they still have to solve the original sin, the password sitting in plaintext user data. Think about it this way. Taping the vault password to the side of the delivery van is exactly what putting a secret in user data does. Anyone who walks past can read it. Instead, you give the driver a company badge, an IAM role attached through an instance profile. At each stop, the badge proves who they are, and the vault opens. The password is never written down on the van at all. Here's that fix as a flow. On the left, the EC2 microservice has an instance profile with a scoped IAM role. Through the metadata service, it receives temporary credentials automatically. Using those, it calls getSecretValue, scoped tightly to just the one Amazon resource name, or ARN, of the secret it's allowed to read. And back comes the secret value. At no point is a credential written into user data. The SDK picks up the instance profile credentials on its own, so the application doesn't change at all. One caveat worth calling out, enforce INDS version 2 on these instances because the older version 1 is vulnerable to a server-side request forgery attack that can leak the role's temporary credentials. And here's what solves MegaCorp's whole problem with no rewrite. The application creates a Secrets Manager client and calls getSecretValue against its secret's ARN. Notice there are no access keys anywhere in this code. The SDK quietly picks up the instance profile role's temporary credentials on its own. The pattern is the beauty of it. The app already used the SDK, so all MegaCorp adds is a scoped IAM policy. And because the app reads the current value every time it starts, when rotation swaps the password on schedule, the app simply rereads the new one. Nothing to redeploy. The Secrets Manager documentation frames this exact pattern in one clean sentence. It says you replace hard-coded credentials with a runtime call to retrieve credentials dynamically when you need them. That's the mental shift. The secret stops being a static string baked into a launch script and becomes something the application asks for at the moment it needs it. That's how MegaCorp's plaintext and user data problem disappears without touching the deployment pipeline. A few things worth locking in. First, forgetting with decryption returns ciphertext instead of the plaintext, and the call looks successful, so it's an easy bug to miss. Second, standard tier parameters cap at 4 kilobytes, advanced to 8, and anything over that 8 kilobyte advanced tier cap would need to move to Secrets Manager or another store. Third, Parameter Store has no native rotation, and Amazon Web Services explicitly recommends just using Secrets Manager rather than hand-building rotation with policies and custom code. And one genuinely useful trick, if a legacy app already reads from Parameter Store, you can store the rotating credential in Secrets Manager and reference it through a special Parameter Store path that points into Secrets Manager. The app keeps its existing code and gains rotation for free. Let's log in what matters. Both stores encrypt with KMS, so encryption alone never decides between them. Only Secrets Manager rotates for you. If a scenario says automatic rotation, generated random passwords, or a cross-region replication, that's Secrets Manager. If it says cheap encrypted config or feature flags with no rotation, that's a parameter store SecureString. And in every case, retrieve the value at runtime through an instance profile IAM rule, so nothing is ever hard-coded. Now let's see how well you absorbed all of this with a quick 5-question quiz. Question 1. A company runs an application on RDS and needs its database credentials rotated automatically every 30 days without writing any rotation code. Which service should they use? Option A, parameter store with a SecureString parameter. Option B, a KMS, customer managed key with automatic key rotation. Option C, an S3 bucket with default encryption. Or option D, Amazon Web Services Secrets Manager. Run the decision rule from earlier before you answer. This one is D, Secrets Manager. The phrase rotate automatically without writing rotation code is the defining signal. Parameter store has no built-in rotation, and KMS key rotation rotates encryption keys, not database passwords, so those are distractors. Question 2. A team stores 300 non-sensitive application feature flags and wants the lowest possible cost. The values never rotate. Which is the best choice? Option A, Secrets Manager with 1 secret per flag. Option B, Secrets Manager with a single JSON secret holding all the flags. Option C, Parameter Store Standard Tier. Or Option D, Cloud HSM with exported keys. Think about which constraint matters most here. The right call here is C, Parameter Store Standard Tier. It's free for up to 10,000 parameters, and these values never rotate, so there's nothing to gain from paying Secrets Manager's per secret fee. Choosing a paid option for static, non-sensitive config is the classic overpay mistake. Question 3. An engineer reads a SecureString parameter with getParameter, but receives an unreadable encrypted string instead of the password. What's the most likely cause? Option A, the parameter exceeds the 4 kilobyte limit. Option B, the call omitted with decryption set to true. Option C, the KMS key was rotated and invalidated the value. Or option D, SecureString parameters can't be read via the SDK. Lock in your answer before I give it away. It has to be B, and here's why. With decryption set to true, Parameter Store hands back the KMS encrypted ciphertext instead of the decrypted plaintext. The call still succeeds, which is exactly what makes this such a common and sneaky bug. Question 4. An EC2-based microservice must fetch a database password at runtime, with no credentials stored in user data or code, and no application rewrite. What's the correct approach? Option A, attach an instance profile IAM role scoped to the secret and call the SDK at runtime. Option B, encode the password in base64 in the user data script. Option C, store long-term IAM access keys in an environment variable. Or option D, pass the password as a launch template parameter. Pause here if you want more time. The right call here is A. An instance profile role gives the SDK temporary auto-rotating credentials, so the app fetches the secret at runtime with nothing hard-coded and no rewrite needed. Base64 is an encryption, and storing long-term keys just recreates the plaintext credential problem all over again. Question 5, and let's test a concept from an earlier episode. A symmetric customer-managed KMS key has automatic key rotation enabled. What does this rotation actually change? Option A, it rotates the database credentials protected by the key. Option B, it replaces the key material while keeping the same key ID and ARN. Option C, it generates a new ARN that applications must be updated to use. Or option D, it deletes old key materials so previously encrypted data can no longer be read. Got your pick? Let's see. If you said B, well done. KMS. Automatic key rotation swaps the underlying key material on a schedule, but keeps the same key ID and ARN, and it retains the old material so previously encrypted data stays readable. And notice it does not touch database credentials. Rotating those is Secrets Manager's job, not KMS's. Keeping that boundary straight is exactly what this episode was about. That's the full picture on Runtime Secrets, Secrets Manager versus Parameter Store. Subscribe if you want the rest of the Cloud Architect path delivered straight to you, no searching required. Drop a comment with the part that surprised you. That feedback genuinely steers the channel. Got an exam you want next? Say the word below. And if anything about the style or the speed would work better for you, let me know. See you in the next lesson.